Okay. Well, we wanted to give about a minute or two for everyone to get in, but I think it's probably a good enough time to get started. So, thank you everyone for joining. Welcome to this masterclass that we'll be presenting. This is a joint masterclass presented by Makersite and SiliconExpert. The masterclass that you're going to see today is on electronics on demand, connecting component data to sustainable product decisions. So we're going to walk you through what this partnership really brings to the market. It's a pretty exciting opportunity or growth in the market, which is going to show how you can really do rapid LCA modeling and compliance based on SiliconExpert data and combined with Makersite, able to really kind of rapidly bring electronic environmental and compliance decision making into the market. And so we're really excited about the opportunity to be able to present this to you today. And hopefully this is educational and it's something exciting for everyone to be able to learn, how this really works and how you could use this within your own workflows. I guess I'll start by introducing myself. So first off, I'm Kevin Dillman. I have a PhD in environmental engineering. I've been working in the space for about the last 10 years. My PhD comes from the University of Iceland. I was working on environmental systems. And now I'm a solutions engineer here at Makersite. Been working here for about the last year and a half. And here I've been really focusing on electronics in my time here and had this great opportunity to work with SiliconExpert and really show, different, various electronic companies that we're now working with, the power of being able to have these electronic components on demand. Now I'll introduce with me my other presentation partner here, Dwight Morse, and I'll let him introduce himself.
Yeah, thanks, Kevin. I am Dwight Morse. I am from SiliconExpert. Many of you might know SiliconExpert, some of you might not, but what we have is an incredibly large database of electronic components information. And some of that information has to do with environmental regulations and sustainability and the chemical makeup of the components themselves. What I do is I work with our sales teams and our engineering team to help customers to find the solutions that they're looking for.
Excellent. Thanks, Dwight. All right. So what are we going to see today? So our masterclass session, we did a little bit of our introduction. So you got to see, who we are, who the presenters are. We're happy to answer any questions that you may have. As you can see in the chat, we're likely going to answer a lot of the questions at the end. But we'll start by just describing a bit about who we are, the companies that are being presented, Makersite, SiliconExpert. Next, we're going to walk you a little bit of what is the day in the life of the electronics manufacturer. What are the challenges that we're often seeing in the market? And what solution does this joint presentation that we're showing you today, this partnership that we have, what problem is this solving for electronics manufacturers? And that's really what this electronics on demand solution is. And we think that there's really kind of an educational use case to this that we're able to present. We'll give a couple real world examples, as well as a couple case studies of how this is being used in other companies that we've worked with. And lastly, as we mentioned, there will be a Q&A, so we'll be able to answer really any questions that we're able to help from there. So I think without further ado, we can just jump into it. Dwight, I know that you just kind of gave a little bit of a brief overview on SiliconExpert, but I don't know if you want to cover anything more here.
Yeah, no. So SiliconExpert has been in business for almost 3 decades now, and what we do is we gather and aggregate information across manufacturers, across distributors, across all of the suppliers about information mostly on board level components. So you've got things like capacitors and resistors, and we look at all of the information that surrounds them. We know where they come from, where they're being manufactured. We know what the chemical makeup of those things are. We know whether or not they've been certified as compliant with environmental regulations. There's some 300 plus attributes that we take care of. And so sustainability is one of the things that we help with, and we're very excited to work with Makersite on that.
Great. And I think that's a great segue into who we are as Makersite. So Makersite is I'm going to go into the next slide a bit of in terms of what we cover, but here I'll describe a little bit of just who we are. So we were founded in 2018, and it's primarily a European company in the sense that it's headquartered in Germany, but we have US teams as well. We actually came from ThinkStep, which is a lot of kind of the background that goes into Sphera and some of these very familiar LCA platforms. And so there's a lot of experience that really was the founding core of Makersite. And now we have over 150 plus employees actually. And really, we have developed to work with a lot of electronics companies and companies that have electronics within their, manufacturing BOMs, and how they make, supply their data. So then we have Microsoft, which is a great example. We have Lenovo that we'd be covering. So these are examples of obviously, very, very well-known and well-established electronics companies. And we've been able to really work with this data and be able to kind of showcase this, how we're able to work with electronics data and to, like, really kind of bring, by our partnership with SiliconExpert, the ability to grab this primary data. And as Dwight mentioned, it's important to reference that what we're going to talk about today is board level components, but how we're able to help manufacturers when you're working with this. So really excited to kind of be able to present how we're doing this. And just to highlight, this is how Makersite works. So of course, we're still in this general overview, but really what we try to do is connect your enterprise systems. So bring together that your CAD data, your PLM data, ERP. So if it's in SAP or in some of your other, kind of enterprise systems, and bring that all together with supply chain data. So that's, LCA data that, or LCA databases like EcoInvent or Carbon Mines, or like WIM, like a World's Metals database that gives you a lot of information. And now with this partnership with SiliconExpert, we also have the ability to get material data. So this is, for example, like what we will be talking about and we're going to showcase. So this is just one more of those supply chain data sets that when we're working with those board level components and we have a manufacturer part number, we're able to bring that material information in, connect it with those LCA databases like EcoInvent, and enrich it as well with manufacturing processes and really bring those LCA models to life through our machine learning AI, in which we're attaching, like really bringing this all together in order to get these sustainability outputs. So as Dwight mentioned, there's also compliance. So if you have those certificates of compliance, you can also get outputs there. Cost is something that we're doing as well. And you'd have the ability to really, that's where you're trying to make those environmental decisions, by understanding what the cost basis is, as well as compared to sustainability. And then lastly, what we're going to focus primarily on today is the sustainability outcomes of being able to do this. But we want to be able to show all the kind of various outputs that you have. But again, we're going to focus primarily on sustainability today. But don't forget that compliance is another important aspect that we're able to kind of really automate through this process as well. So we're going to bring you into the day of the life of electronics manufacturers. So what we really want to do is kind of capture what's the problem that we're seeing in the marketplace and what does this partnership solve? And so that's what we're going to be covering here. And who does this really influence is the sustainability teams, engineering, and procurement, because primarily, these are really for the board level components, which are being sourced externally. So then that's the procurement team. They're in the kind of like purchasing side, and then they also have to make decisions of who to purchase from. Engineering is, of course, designing the boards and deciding what components go on it. So then that's another important factor. And then, of course, the sustainability teams, because what we're really trying to focus on is the eco design and the ability to improve the designs from an environmental lens. And then, of course, taking cost and, the engineering, requirements into consideration when doing so. Okay. So maybe to start with, why is this even important, or why, especially from the sustainability side, do we need to care about this regulations, this reporting, this eco design? And of course, I'm not going to dig too much into this because this isn't necessarily like kind of the core kind of purpose of this presentation. But there's a lot of these regulations that are coming onto the market. So you have ESPR, CPR, you have CBAM, CSRD. So all these regulations are really starting to come into force, and it's in this kind of like preparation stage in which this either reported or you need to start responding to these regulations. So this is where, this is what's really kind of a driver of what's really like why it's becoming a requirement for these sustainability departments within the electronics manufacturers. And what this is also creating is a lot of demand within the supply chain. So now that, one company, let's say a Microsoft at the very end, says, hey, we have these laptops which we want to report sustainability information, but they have, hundreds, thousands of suppliers that, they need to understand what is the PCF or material kind of data that's coming, downstream or upstream. So then they go to the next supplier and they ask, okay, well, where are you getting your, like, what is the PCFs of your components? and what's in that. And they're probably kind of, doing assemblies and having components that they are putting all together. So then that kind of creates this network effect pushing up and down the supply chain. And that's what's really driving a lot of this demand that we see within the electronics sector for why this PCF data and why worrying about eco design is important now. One last part to this, of course, is that DPPs are also coming. So you need that ability to kind of really manage all this information. So it's just kind of one more regulation and one more kind of reporting requirement that's going to come up. And electronics is very likely to be in this in the next product groups that are coming. So it's just going to be increasingly important to be able to respond to these regulations. Okay. So now that we understand kind of the why that these sustainability teams need to report on this, or that electronic manufacturers are concerned about how they are going to be able to report on this environmental information, we want to get a little understanding of what does the data landscape for a typical electronics manufacturer look like. So oftentimes what we'll see is that you have your bill of materials information, and you may have this in a SAP system or a PLM system more likely. And within this PLM system, we're going to show you what a kind of standard bill of materials might look like. You may have some material data. This may be in your CAD system or your PLM. So you kind of understand, what materials you're using if you have especially physical components, but you likely don't have that deep level material data for board level components that you're purchasing, because of course you're not the one manufacturing them. So maybe you don't exactly know what materials are in there. That's where having these FMDs or full material declarations is very important. And where you get these FMDs are often, we'll kind of explain this a bit more in a second, but it's from these IPC 1572 files is, really how they are kind of shared within the electronic sector, particularly for these board level components. But often you don't really have these on hand. You can go and do outreach, and a supplier may even have these in Excel files. But the problem is that oftentimes this data is not harmonized. It's difficult to collect. It's very time intensive that you may have thousands of components that would require these full material declarations. And if you have to go and manually request these from your supplier, harmonize all this data, get it into your system, and then still enrich that by yourself, this is an extremely, kind of labor intensive process. And that's what this partnership really kind of alleviates. That goes alongside with these certificates of conformity. So these COCs. So these also are for the compliance side of the house that we were talking about. And again, one by one, you have to reach out to your supplier in order to get this information. So the ability to get those COCs on demand is extremely valuable. We're not going to talk too much on the transaction side, but I'll just kind of cover quickly is that for the transaction, that's really kind of for scope 3 reporting. The site data, that's more for your in-house manufacturing. And lastly, customer data. This is where maybe you also may be collecting those FMDs, but again, these are very kind of difficult to collect at scale. So that's why what we're talking about today is going to be relevant. So what does this look like? So I'm going to give a little bit of coverage of, what do we typically see when we're working with electronics manufacturers? And that's where you may see that they have that electronics manufacturers have kind of 3 types of parts. So it's first off is going to be the off-the-shelf components. And so this is oftentimes what we're seeing, those board level components. And it's really what we're going to focus on today. And we're going to zoom into that in a second. The second thing that we see are mechanical. So you can think, I don't know, a laptop or another device is the plastic, the chassis, the metal. So those types of things that are kind of built around the electronics. And the last thing, there may be some in-house manufacturing that's done depending on who the manufacturer is that we're discussing. But they may have some, let's say a PCB board, and maybe, we actually know you may have a stack up file, or you may have something that actually has the specific material information. So then there may be kind of one last level of, or, type of data that we see as we're working with these manufacturers. But today we're really going to focus on number 1, those off-the-shelf components.
Yeah, and what I wanted to show here, and this is really the beauty of the relationship between Makersite and SiliconExpert, is that in the previous one, you saw those off-the-shelf components. And lots of times a manufacturer will have more than one component that is qualified to use in any given design. And what we're doing here is we're looking for cross-references. We're looking for qualified alternatives basically to a part. And one of the things that we can do, because we have all the information on these parts, is we can take a look at the part that we have on our board currently, and then compare it with some other alternatives and look at the compliance information. You can see here Reach and Ross and that sort of thing. So we can not only tell you, whether or not the part could be used as an alternative, but we can also tell you, what the compliance status is for that part. And it's really it's a wonderful relationship between SiliconExpert and Makersite.
Yep. Perfect. So really, and to like build off of what Dwight was saying, is that we have these different parts that you're able to kind of see those alternatives and see the ability to really understand, okay, we can go with this component or this component, and do that on a feature basis. And what we're going to be able to then do is add this environmental criteria. So this is one thing to kind of really understand, as well as how this data is sometimes managed within these electronic manufacturers. So first off, typically what we see is that, there's an understanding of, what this component does. So it may be a VR controller or a resistor or a capacitor. And then what you have is pretty much just an NPN, and you have units. So this becomes very difficult when you're an LCA modeler, is most often, let's say when you're working with Sphera or EcoInvent, with like the Gabi database for Sphera, is that oftentimes it's like weight based. And so it may be like, okay, well, if you have this many grams of a resistor, but often that's not really how that data exists within databases. You often just know how many like units of a resistor that you're putting on a board, or how many integrated circuits. So this makes it very kind of difficult to then apply these LCA data sets. And so that's where, and it's not, supplier specific. So you just kind of have a rough idea of the weight, and then you're applying this kind of very generic data onto it. So instead, maybe you can have this NPN and you can get that like actual information. And this also supports the ability that if you have alternatives, you can then add environmental decision-making, like environmental criteria into the supplier selection. So that's where the benefit of being able to see what an NPN looks like and what that alternative looks like, and be able to kind of really then see that comparison. And that's something that we're going to show you shortly in this demo. So what does this really solve is some of the sourcing challenges is, when we're looking at that is data accessibility, and, really that there's varying data quality standards if you're going and trying to get this data, from suppliers. And that's that second point of this varied data formats. So then there's another challenge of how do you integrate all this data? And so, you have this from all these different databases. It might be from different formats. So how do you bring this really all together? There's also the challenges that when you send out surveys, you end up with kind of inaccurate data. They may give outdated information. Maybe the manual entry is difficult. So it makes survey data is a little bit challenging. This leads to inconsistency. And then oftentimes you end up with incomplete data. So it becomes a very kind of challenging prospect to then go get information for what could potentially be thousands of components. So that's what we're going to talk about today, is really how this partnership helps to resolve this problem. So what I'm going to do is kind of give an overview of really what this new electronics demand approach looks like, and how this is really going to benefit electronics manufacturers that are using these board level components. And so we're going to just kind of start with, what does this process flow look like? So first you have your bill of materials. So you're going to have a bill of materials, and that bill of materials, obviously in this case, we're talking about ones that contain these MPNs, or these manufacturer part numbers, which are those kind of unique identifiers for each of those board level components that, we may be able to get information for. So that's what we're really going to talk about here. And that's really our first stage. And we're going to primarily be talking about how this really develops PCFs, or product carbon footprints for bill of materials. But there is the compliance aspect. And as I mentioned, I'll kind of like touch on that as well, of what type of data that you get. But what we get is this IPC 1572 file that allows you to kind of get this material information. I'll talk a bit shortly afterwards about the closest match approach. So then what we're going to do is find very similar features. And this is something that later on with SiliconExpert we can do as well, is like look at the metadata associated with that part. And then even if a 1570, like if the FMD isn't available, you may be able to find like a very similar component that you can use as an effective proxy in order to do the modeling. And then lastly, of course, then there's some kind of last steps, which we'll talk about, of what you can do if you don't really find that information. But the Silicon Expert, because of how many components they have that are in the marketplace, really provides very good coverage. So the first thing that I'm going to show you is this first stage. So this is where you have an MPN, and we're going to give an example here. Is that for Texas Instruments, for example, that maybe you have this differential comparator on your bill of materials, as we were saying before. So kind of one of those line items for a board level component. And so what we do is we go and find that FMD IPC file. So maybe I'll just cover it quickly so I'm not, making acronym soup for you all. But basically, you have this IPC file, which is, and it's the 1572, and that's essentially the data format to provide an FMD or full material declaration. And that's what you're really seeing here. And so this is the IPC, kind of data format. And so you have this homogeneous material list, which is essentially telling you, okay, well, these are the type of materials that are inside of it. And then within that, you have the actual substances. So you may have a bond wire, and that bond wire is made of copper and of silver. Or you may have this lead frame, and then that has all these different kind of sub-materials within that. So you're getting this full material disclosure, and you don't see it here, but you're also getting the cast number, you're getting the weights. So this is really an effective way to get very specific supplier information about the exact materials and exact weight of the units that you're using. So that's where it's a big, kind of improvement from, let's say eco-invent modeling, where maybe you're just trying to estimate like, okay, maybe this thing weighs like 0.05 grams, and we're just going to model it using like a generic surface mounted, let's say resistor, or in this case, integrated circuit. Rather, you can see where you have this lead frame. Now you can see it inside of Makersite, for example, where we would immediately just get this data, and without, any LCA modeler or anyone having to go in, because we have the cast numbers and we've trained our AI model on this, we're able to rapidly do this mapping and build an LCA model on the spot. And we'll showcase this shortly in a demo. But basically, you can see on the lead frame that not only do we bring in those materials, so you can see the nickel, the gold, the palladium coming from the lead frame plating, we also add this generic electroplating activity to add all those kind of like manufacturing processes that sum up into this. So it's not just the materials that you're getting from the FMD, but we're also now enriching it with the manufacturing processes in order to give you basically an LCA on demand for these electronic components. So you can see that for the lead frame plating, where it has the generic electroplating activity. The mold compound, you can see that that's kind of injection molded because that's the likely manufacturing process, for that subcomponent. And then lastly, at the highest level, then we have the integrated circuit manufacturing, where you can see the energy use associated with that manufacturing. So really bringing this all together to on demand create LCAs for each one of these MPNs that you're doing, and making it in a supplier specific way. So this is really kind of the big development that's taking place. And what this gives you is this LCA model on demand. So you get this cradle to gate LCA with a fully transparent supply chain. And in Makersite, you're able to see, for example, for this exact Texas Instrument MPN, you can see the IC manufacturing, you can see the doped silicon, you can see the lead frame that we were talking about. And what you're seeing on the Sankey diagram is the relative impact, or size of it. So you can even see, okay, well, that much of the impacts comes from manufacturing. This subcomponent is, the doped silicon is, let's say, 40% of the impacts for this product. And then you also can actually drill down into this. So that's the table on the right here. And what you're able to then do is break it into, you have your manufacturing, you can see your plating, and you can see the impact from every single one of those materials and manufacturing processes. So that's really what we mean when you're getting those LCAs on demand from this. That's just like how that first stage that I was talking about in this diagram. I'll flip back. This is what this looks like. So that's what we go. We find the MPN, we create this LCA on demand, and we get that PCF for you for that specific MPN. What I'm going to cover now is that closest match, where we use this metadata. And what we're basically doing here, and I'm not going to cover it too much because this isn't exactly what's built in with SiliconExpert right now. But what we're doing is we find that MPN, but where it would be where we will kind of advance, and we already are doing this to a degree, is we're taking these technical parameters. So you may have a resistor with a circuit with a certain, kind of length, with resistance kind of parameters. And then we understand what category it's in. So, I mean, it could be an IC with a specific package type, or whether it's a ceramic resistor or another type, or ceramic capacitor. And then, so when you're looking at this, then what we're going to do is like match something with kind of like, kind of a ordinal matching to understand, okay, is this a very similar type part? And if so, great. We're going to go find a closest match. So at least you have a very good proxy for this. And we're not just using kind of like a generic eco invent, data set. So, and then if not, of course, if the closest match isn't good enough, then we just don't apply an MPN to it and move on. So, well, I'm going to do a quick demo here in a second. And what we really want to show is when we're looking at those alternatives, and I'll slide back to that slide, is how does this enable environmental decision-making or eco-design when you're working on these products? So I'm going to flip back to the bill of materials portion because I think it will just help make a little bit more sense. So when we're looking at this BOM, you can see that it's this simple server, or it's going to be called in the demo a simple driver, but it's the exact same bill of materials. And then what we're looking at is how there's this alternative, and I'm going to drill in here. So you're going to have this like sub level of electronic components. So I'll shortly show you in Makersite how Makersite is able to build the BOM structure of, let's say, this electronics component of the simple driver, and then drill into these electronic components, and then show, okay, well, how can you add this environmental criteria, or how can you look at these different alternatives within Makersite or with any tool to then understand, okay, well, what are the benefits of looking at one MPN versus an alternative and see that. So that's what I'm going to show here in a second. So one moment, and I will share a screen. Okay, so now it seems that you can see my screen here. So as you can see, we have this simple driver. And like we said, this Sankey diagram, if you look from right to left, you see that it's 7.75 kilograms of CO2. You can then go over to the PCB board. You would see that that's 4.68 kilograms of CO2. And so what we're going to do is drill into the PCB board. So now we can drill in here. You're going to see that PCB board. You would see there's this manufacturing energy use, the actual kind of materials associated with the board, and the electronic components. And as we said, that's where we're going to do the focus today. And now you can see that like we had those, let's say 7 electronics, different components. And you can see that the resistor and capacitors, often these are like the much less impactful components. The integrated circuits are often the ones which have a higher impact. And the VR controller was one of those where we had those alternatives available. So now if we look at the electronic components, the sum of them leads to 1.17 kilograms of CO2. So that's kind of the carbon footprint for those electronic components portion. And what you're able to do then is do a substitution. And because we've already said that this is an alternative, you're able to swap one with the other. So now it's like, okay, well, we had these 2 different components. What would happen if I were to swap one for the other? So you can see that these are slightly different MPNs. So these are the alternatives that we suggested for the system. You can see where this one has like the AMT and this other one is, missing that. It's a different number. So we're going to apply that selected pin. And shortly here, you'll see what happens is this actually by swapping those components, you actually lead to a 10% reduction in your carbon footprint. So this is where that environmental decision-making that maybe with the same exact features, but because now you know the material difference between the two, if you're able to swap out those components and understand the difference in impact, now you can really make an impactful kind of change to the environmental impact of the component that you're building. And especially, once this gets into the hands of the engineering department, they can make these designs earlier on. And so that means pre-manufacturing and not just kind of post-reporting. You're able then to make these types of impactful eco-design decisions, which can improve the environmental performance of your products. So that's really the key benefit here. And it's worth noting too, that this is where that we've been focusing on climate change, but this is an LCA model. So you're also able to swap between impact categories. So for example, we could also switch between water use. And then you can see that would lead to a 11.72% reduction in water use, because again, this is an LCA model. So not just are you able to see the benefit in terms of carbon, but in terms of, various different of all the different impact categories that you can think of. So that's going to end our demo here. But we just wanted to show really like kind of what does that look like in the day of life as you think about engineering, procurement, all these types of things, like when you are, trying to add that type of decision making when you're doing this design for, board level components, and the benefit of being able to do this so rapidly. Corinne, do you mind maximizing the slides again? Okay, perfect. All right, so now we're going to move into a real world example. So you can see how this happens one by one, but how are you really thinking about this as you're working, across 4,000 MPNs? So this is kind of a customer situation that we saw. So it's, really a Fortune 100 leader in digital infrastructures. There's some requirements from customer, like there's customer PCF demand. So, and they had this long list of MPNs, and they don't exactly know how to model it. Maybe they know that these are resistors, but is it really that helpful if you have a bunch of MPNs and a bunch of resistors and you're just applying a generic weight and then using a generic data set? Not really. So it's really, okay, if we can model all these MPNs, then we can start to do some decision making. But if we're just using kind of generic matches, that doesn't really help us. So then what we're going to show here is what does this look like as we're looking across this use case? There's not that many MPNs because this was kind of like an exploratory pilot to understand what are the capabilities. So maybe we started out with 4,172, kind of MPNs. And I mean, this was a grouping of MPNs that are across a subset of products of theirs. But okay, what happens then, like after we remove duplicates? So they had 3,400 roughly unique MPNs. Okay, so what's the next step? Now with this new partnership with SiliconExpert, we're able to go and find that FMD information, so those MPNs, and to give you kind of a gut feeling of what type of coverage this gets you. Oftentimes we see that it's between 60 and 90%. That's kind of roughly what I've seen, at least from my experience, when we're working on these board level components, that we're able to go and directly get those IPC files. So where previously this would be, a huge amount of work, and like this is across 2,600 components, that maybe, what the original state would be that you would have to go to your suppliers and for 2,600 components request, hey, do you have the FMD data available for this specific component? Can you please provide it? And that may be across 80 different suppliers. And so you may end up with 80 different data formats that if they're providing this in Excel files that you need to consolidate, harmonize, try to work across, and then you still need to add those manufacturing processes to get that if you want, like, let's say MPN specific data. And so this obviously is, almost exhaustive and kind of almost a barrier to really kind of completing LCAs. So by doing this, suddenly we have 76% of those data sets. Now, if we add those closest match, where if we have those technical parameters, for example, the ones that are available in SiliconExpert, we could compare those, bring them together, do this type of like estimation to get these parameters available for these different MPNs, and then try to find this closest match. Maybe that gives us an additional 14% gap coverage. So now between the two, we've essentially have 90% of your data gaps covered. And then, okay, now the last 10%, sure, these are maybe a little bit more difficult. Maybe they're very unique chips. Maybe they're connectors that, they're kind of just simple little plastic parts that there's not like a IPC file available for. Or, it might be PCBs, for example, or something that data isn't exactly like super available in the market. So then that's where you try to understand, okay, maybe this is now where we do direct supplier outreach. We can do different proxying, but maybe suddenly this becomes a data gap coverage of, oh, we just need to worry about 5%. So now maybe before where it went from having to deal with 3,400 parts, maybe now you're working across 100. And now this is actually, like a bite size or kind of manageable amount of data that you can try to tackle. And that literally almost kind of makes LCA from like unapproachable to something that you can actually do. This could save, and I mean, literal hundreds of man hours. And we've seen this in terms of how to actually go to market and get all that data and do the supplier engagement, because it allows you to really take a much more targeted approach and, really reduce the amount of supplier engagement that you have to do, which can save a lot of time and a lot of money. So we have a few case studies that we'll cover, and we can kind of go over this a little bit quickly, but just a few examples of electronics companies that we've worked with to, really work with completing LCA at scale. So the first one is of course with Microsoft. They've highlighted the LCAs that they've done, so that they have they've been able to use Makersite to kind of leverage doing LCAs at scale. They were then able to make an emissions calculator out of the results that they were getting from Makersite. And then lastly is that, of course, from the eco-design perspective, that they've actually had, real use cases of how they've been able to reduce their manufacturing carbon emissions through the eco-design kind of capabilities within Makersite, and, how this really has supported Microsoft in reducing their carbon footprint. And so here's another, so this is like another good use case. So for example, also the improvement of going from primary data or, kind of secondary data where maybe you're using a lot of these, secondary data sets that are just kind of like generic averages. So then you're actually getting that, specific primary data from your suppliers. So you can make a lot of those, environmental criteria. So you can see how, at the beginning that maybe they just had 20% of their footprint from supplier data, and how that really grew up to 70%. And because you're getting actually those FMD data, and this allows for a lot more kind of like very specific and supplier specific data that allows you to make that environmental decision making that we've been really covering throughout this masterclass. Yeah, so then we'll go here. So we'll talk about then as well Lenovo. So we've had some examples with them that, we're also been helping them kind of acquire these FMDs, and they're able to kind of do now configuration level reporting. And what we're able to do is then also, as they're kind of seeing these different boards, they're able to swap out different components and then do different configurations to then be able to show what the carbon footprint is for each configuration. And this particularly, as they're selling to different enterprises, they're able to get a unique configuration where there could be millions of options, but choose the right one that they are selling within this use case and get the PCF for that specific product that would be being sold. So this is another just good example of like how you can make use of all this LCA data to get these various outputs. With that, I know we wanted to leave enough time for questions and answers, and also give some time back if we have extras. So I think we can hit pause there, and hopefully answer any questions that you have for us. Okay. It seems that we are getting some questions in the chat. Corinne, do you want to like moderate, like just like asking the questions,
Sure.
or should I just read it in?
Sure then. We had a few questions on FMDs. I think this is primarily towards SiliconExpert, but can be a joint question. What percentage of parts published in SiliconExpert have an FMD?
So
And
Kevin
then
touched on this.
also is the location. Oh, sorry, go ahead.
I was going to do it one. I thought we were going to do it one at a time. So to answer this first part of the question, Kevin touched on the fact that I think you said, Kevin, you saw between 60 and 90% of the off-the-shelf parts having an FMD. A lot of this is going to be determined by, just whether or not these parts are custom or not. So if they're publicly available, then most likely we're going to have that information in our database. And then the next question, I think, Corinne, was around the location of manufacturing being determined as part of the FMD. So SiliconExpert knows where parts are manufactured. We know where the fabrication site is, and we know where the assembly and the test sites are. However, a certain component may be manufactured in more than one region. And in fact, that's what you want nowadays, especially, right? You want to be able to not have a single point of failure. So we can't say with certainty exactly which sites any one component, your component, is coming from. You would have to know that from, either if you're getting it direct from the supplier, or if you're getting it through a distributor, they would know where they're getting that part from. And then the last part of this question was, from working with FMDs, this customer is aware that they can have a lot of data quality issues. So incorrect mass or cast number. Does SiliconExpert perform some sort of QA and validation in this case? So we don't look at the components ourselves and test the components physically. What we do is we get the information from from the manufacturer, from the supplier, and we aggregate that information into our database. If there is a discrepancy that people become aware of, then we can certainly contact the manufacturer in that case, and ask if if a mistake has been made, and then correct that, both with them and in our site. But we don't do physical testing, if that's the question.
Yeah, and maybe I can just like tag onto that, is that there are QA checks within Makersite. So once it gets imported, we have QA reports in which you would like one thing that it does is like make sure that the sum, like the weight of the components sums the like kind of the final weight. And so there's kind of QA checks to validate like weight sums. And then also you'd be able to see the mass within Makersite and the impacts. So if they accidentally put like 1 kilogram instead of 1 gram, you're going to see that within the impacts and very quickly be able to identify where those problem data sets are. And then oftentimes it might just be a unit change or something like that. And we're able to kind of quickly edit this. And then in terms of cast numbers, I think like if it was a extremely incorrect cast number, I think it would stand out, or not match within Makersite. And then there would be like, maybe a small percentage of the parts that are not exactly matched right away. And then, so that's another example of like where it might not exactly be a QA, but there would be some kind of like validation checks or things that you can do during the process to make sure that you're mapping it correctly.
And then our next question is about IPC files. Are the IPC files provided by the customer, Makersite, or SiliconExpert?
Yeah, so they exist, essentially, I mean, and Dwight can talk to this, I think, as like, they have a database of these IPC files. So these are provided that already exists in SiliconExpert, and we're able to go and grab those for you. So the answer would be that like it is this partnership providing those IPC files and not the customer.
Well said.
Okay. And then I believe another one for SiliconExpert. Has SiliconExpert come across cases where similar parts with the same underlying manufacturing process or technology from different suppliers has significantly different material compositions that ends up impacting the PCF? Is that an often to be expectation scenario?
Well, I think it's basically how the parts are manufactured, right? So unless they change the way that the parts are manufactured, you're not going to see a huge difference. I think that people are more engaged when it comes to what are the materials that are going into these parts, and there are more and more regulations. There were some that Kevin covered, but the number of regulations and the number of regulating bodies that are concerned with substances are very high concern about these substances is increasing. And so I think that when you go to have a new tape out, basically where you've got a new component and you're going through the manufacturing process, you're thinking about this more at the beginning than you were before. But normally the reason why the components have the materials in them, batteries, for instance, have heavy rare earth elements, is because of their properties. And so some of these are unavoidable. And so you don't see a ton of difference between one part number in a product line and another one.
Okay, so our next question is there metrics or information on the accuracy of the numbers in the database and also the closest match approximations? Is there maybe something like an option to do a sensitivity analysis?
Dwight, maybe if you could just talk about like the metrics accuracy of the numbers in the database, and then I can take the closest match and sensitivity analysis questions.
Yeah, so it's like a lot of things, right? We're getting the information that we're getting, and we're getting it directly from the supplier. So the accuracy should be 100%. That isn't always the case. And what we'll do in the cases where somebody brings up the fact that something doesn't appear to be correct is we've got relationships, and we've got, like I said, almost 3 decades of history with relationships with these suppliers that are making these components. So we're able to get to the information. But for the most part, yeah, we believe that the information that we have is very accurate.
Yeah, and then as far as the closest match goes, there is going to be like there is a tag basically that says, "Hey, this was a closest match," not like pretending that it's a direct match or something like that. So we do identify it in terms of like metrics on this. Like I know that we do kind of a like vector based like approximation because we're working across these like like many different features. I don't know. I don't think that we give like because I think it would be like meaningless or kind of this unitless vector that would be very difficult to understand. So I don't think we necessarily give like a metric on it. But we do kind of tell you if it was a closest match, and I know that it's only done when it like this vector search is like very close to each other. In terms of a sensitivity analysis, I mean that is something that you could maybe do kind of between the two like products that you're comparing. But I think that's something that like it would be a deeper level question that I think would be difficult to kind of answer here. But I would just say that there is like kind of those capabilities, but it maybe isn't exactly like something that's going to be done. Like you would maybe have to set that up a little bit instead of it being done on the fly.
Okay, so we have a few questions about PLM. When PLM is Team Center, will it be deployed as a module of Team Center or hosted outside an OEM network? And also, if the BOM is exported to Makersite, will that data be used for training at Makersite AI?
Sure. So I can take that. And yeah, so when the PLM is Team Center, for those who aren't aware, is that Makersite as well has a partnership with Team Center. So we're able to actually kind of get this data like back and forth and have a two-way connection between Team Center and Makersite, in which we're able to kind of get that bill of materials. And if you have the MPNs, this is going to be, because it's a part of Makersite and Team Center has this partnership with Makersite, this whole process would exist. So you would have MPNs, and we have existing projects that look like this, where we receive a bill of materials which has MPNs. We get these IPC files, we do the auto modeling, like kind of like extracting those MPNs, doing the modeling on it, getting those outputs, and then you would get those outputs and be able to share back to Team Center and get the environmental impact. So yes, absolutely. Like this is, this would be deployed as a module of Team Center. We have to set this up like, I think that this is like a sustainability module within Team Center. There's a whole partnership kind of model built around that. So I think if you need to talk to your Team Center rep, they can bring us in. We have a very good relationship with them, and we can just make sure that it would work for you essentially. Yeah, and when the bomb is imported to Makersite, like the training of the Makersite AI, this is one thing that's just good to know for anyone that we're working with is that we are training kind of like machine learning AI models on your data. But this is only specific to you. We don't ever like that doesn't go shared. It's not going into an LLM. It's more of a machine learning based model. So we're not sharing this with ChatGPT or Gemini or anything like this. So it's not going into any LLM models, nor is it like nor are we using it to train from one team and then go train that on another, because the bill of materials for one company very likely doesn't match the bill of materials like nomenclature and way they describe things on a second one. So these are all kind of like in-house models that don't get shared. So just to make it clear that we're not using your data to train for kind of future projects, and because it really wouldn't be that helpful as well. So that's just something to think about there.
And that's all the questions we have. Okay, well, everyone, thank you so much for joining. We will be sending the presentation as well as the recording after the masterclass. So please look out for that email, and also will be available on YouTube. And so thank you for joining today.
Excellent. Thank you all very much. And thanks for joining me, Dwight.
Yeah, thank you, Kevin.
All right. Thank you. Bye-bye.